Hi everyone, today I would like to share an example on determination of axial forces of a truss system using the method of joint. Okay, this truss is subjected to a uniformly distributed load of 35 kN per meter along member ED and a horizontal load of 40 kN at F. It is supported by pin support at A and roller support at C. Okay, the first step is free body diagram. Okay, for free body diagram, we need to show all directions of the reactions and load applied to this truss. For example, at support A, it is a pin support. For pin support, we have two reactions, vertical reaction and horizontal reaction. Meanwhile, at roller support, we have only one reaction of VC, okay, vertical reaction. Now we go for second step is to calculate the reaction at the support. In order to calculate the reaction, we can use moment equilibrium equation, vertical equilibrium equation, and horizontal equilibrium equation. Okay, we first take the sum of moment at joint A to be 0. From this equation, we can solve vertical reaction at C. So, if you refer to these equations, we go one by one. The first one is load applied at joint F. This load is rightward directions. If you take moment at A equal to 0, this load will rotate in clockwise directions. If clockwise direction, it becomes positive here. So, positive 40 kilonewton times 2 meter. 2 meter is vertical distance from F to A. And then plus 35 times 3. 35 times 3 is UDL, this uniformly distributed load times distance 3 meter. It becomes point load at center of this member. Okay, point load. And then distance, horizontal distance from point load to point A is 3 over 2 plus 3. Okay, this distance. And then minus this UDL will rotate in clockwise direction. That's why you can see positive here. Okay, for the VC, this one rotates in anti-clockwise so that the value or the sign is negative. Negative VC times 6 meters. 6 meters is horizontal distance from C to A. From this equation, we got vertical reaction at C, 92.08 kilonewton. Okay, now we take the sum of the forces in the vertical direction to find another vertical reaction. So in this case, we need to find VA. Okay, so going up direction become positive, meanwhile for going down directions negative. So in this case, VA and VC are going up. Okay, both are going up directions or upward directions, so that the sign is positive. Okay, for the 35 times 3, this one is point load due to UDL. So the direction is negative because going down directions. So VA equal to 12.92 kilonewton. And finally is the sum of the forces in a horizontal direction. So that in this case we can find HA. Okay, if you refer to this one, HA is rightward directions and 40 kilonewton also rightward directions. Both are positive sign. Okay, for horizontal, the sum of horizontal directions, rightward directions is positive, leftward direction become negative. So in this equation, from this equation, HE equal to 40 kilonewton. Okay, for the step 3 is determination of the axial forces. Okay, for this to solve this, using this method of joint, we need to select a joint with minimum number of unknown, normally not more than 2 unknown, and analyzing using vertical equilibrium equation and horizontal equilibrium equation. Okay, firstly we go to joint F. If you refer to this joint or joint F, it has 2 members. The first member is FE. Second member is FA. So it means that it has 2 axial forces or 2 unknown. So that's why we are referring to this joint. And this is free body diagram for joint F. Since there is no vertical reactions, we found out that the FFA or axial force for member FA equal to 0 kilonewton. So by the sum of the forces in the horizontal directions, we found that FFE, or axial force for member FE, equal to negative 40 kilonewton. Okay, next we go to joint D. If you refer to this joint D, we have two unknowns. Okay, the first unknown for member DC, second unknown for member DE. However, if you refer to member DE, it has a uniformly distributed load. It is subjected to a uniformly distributed load of 35 kilonewton per meter along member ED. Okay, firstly, we need to convert this UDL into point load at center of this UDL or this member with a value of 35 times 3, where distance for ED is 3 meters. And after that, you need to transfer this point load to joint D and joint E. So, become 35 times 3 divide 2. So, we got 52.5 kilonewton at both joint D and joint E. So, we divide equally for both joints. Okay, now we go for this free body diagram at joint D. So, by the sum, okay, from the sum of the forces in the vertical directions, we found that the FDC is negative 52.5. Meanwhile, there is no horizontal load applied to this joint. FDE equal to 0. Okay, next we go to joint A. If you refer to this joint, we have 3 members. The first member is AB, second AE, third AE. Okay, if you refer to this joint, we have 2 unknowns due to axial force for AB and second is AE. For AF, we are referring to this one, this value, 0 kilonewton. Okay, now we go for this free body diagram. At joint A, okay, you can see here is an inclined member or inclined axial force, FAE. So for this case, we need to find the angle theta 1 using this theorem Pythagoras. Theta 1. Vertical distance is 2 meters and horizontal distance is 3 meters. So from this theorem Pythagoras, we can calculate the theta 1. And we got the value is 33.69 degree. Okay. Okay, by sum, okay, from we take the sum of the forces in the vertical directions. So equal to 12.92, this VA, plus FAF, this one, plus FAE sine theta. So for inclined axial force, we need to multiply with either sine or cos, depend to the location of theta. Okay, in this case, for vertical, so we need to multiply with sine theta 1. So from this equation, FAE is negative 23.29 kilonewton. Okay, second, we use horizontal equilibrium equation to find FAB. So equal to negative 40 kilonewton. Actually, this, if you refer to these directions, this reaction HA, the direction is rightward direction. So I just maintain the direction as positive here. However, I simply take the value of negative 40 into this equation, plus FAB plus FAE cos theta. For horizontal directions, FAE multiply with cos theta. Okay, so from this equation, we got FAB is 53.38 kilonewton. Okay, the next joint is joint B. If you refer to this joint B, it has 3 internal forces. The first is the first member, the first member is BA, second is BC, third is BE. Okay, now we go for this free body diagram. Since there is no vertical load applied to this joint, FBE equal to 0. Okay, and then by using horizontal equilibrium equation, we can identify FBC, whereas FBC is positive 53.38 kilonewton. Next, we go to joint C. Okay, at this joint, we can calculate or we can determine axial force for member CE. Okay, now we go for joint C. This joint. If you refer to this joint, it has 3 members, but only one member that we need to calculate, FCE. Okay, for FCD, you refer to joint D. Meanwhile, for FCB, you refer to joint B. Okay, now we go for this free body diagram. Okay, this one is the free body diagram. Okay, if you refer to this one, FCE is an inclined axial force. So you need to consider this angle or this theta. Okay, by using vertical equilibrium equation, we create the equations. Okay, so equal to 92.08 plus FCD negative 52.5 plus FCE sine theta. So FC is negative 71.35 kilonewton. Okay, now come back to the value for each axial force. Okay, FFE, the value is negative 40 kilonewton. It means that the member FE in compressions, if your value is negative, it indicates that the member in compression. Okay, FDC also in compression. And then we go for FAE. Yeah, the member in compression also. FAB, okay, the value is positive, positive 53.38. It indicates that the member in tension. If positive value, it indicates that the member in tension. FBC also in tension. Meanwhile, FCE in compression. Okay, next step is for checking. Actually, checking is an important step in order to identify or in order to know either the reaction that you calculate, either the axial forces that you calculate, right or wrong. Okay, we can use this checking. Normally the checking carried out at the unused joint. In this case, the unused joint is joint E. Okay, so this one is free body diagram at joint E. Okay, if you refer to this joint, it has 1 point load from the UDL. Okay, and then we have FEF, FEA, FEB, FEC, and FED. Okay, turn back to this joint E. And then in order to make sure all the reactions and all internal force calculated right or wrong, it must be ensure that vertical and horizontal equilibrium equation, the value equal to 0. Okay, now we go for vertical equilibrium equation first. So if you refer to this equation equal to 52.5, this value, minus, this one is negative because downward directions, minus FEB also downward, minus FEC sine theta, minus FEA sine theta. So from this equation, we got negative 3.266 times 10 power of minus 3. So this value is approximately to 0. If you got this value, it means that the equation okay, or the reaction and the axial forces based on this equilibrium equation okay. Okay, next is horizontal equilibrium equation, and this one is the equation equal to FED. This one is rightward directions plus FEC cos theta 1 for this one, minus FEF. FEF is leftward direction, that's why negative, and then negative FEA cos theta, also leftward directions, and then you got 0.01163, so approximately to 0 kilonewton. Okay, also. Okay, next step is tabulation. I preferring you to tabulate into this figure. Okay, for example, we take member AB. Okay, this one is the joint A and this one joint B. Okay, we got the value is positive 53.38 kilonewton for FAB. If you got this value, it means that the member in tension, and this one is directions if the member in tension. Okay, now we go for second example where negative value. So for example, member AE, okay, the value is negative 23.29 kilonewton. This one for member of axial force for AE, FAE. So the value negative means that the member in compression, and this one is directions for compression member. Okay guys, I hope you enjoy studying and learning